Hey there, everybody. We're going to be taking a look at a recap of all things absolute value in terms of solving equations as well as solving inequalities. So we'll start with this very first example right here. We're asked to solve this equation in here. You'll notice that the variable that we're trying to solve for is right there, x, which is inside of the absolute value. So what we're going to always want to do is isolate this absolute value. So in other words, what I've circled right there, get that alone on one side of the equation. So you can see that since it's multiplied by 3 and then 2 is also subtracted, we're going to have to undo those couple of things. So the first thing we're going to need to do is undo the subtracting of 2. So we're going to have to add 2 to both sides. And that's then going to give us that 3 times the absolute value of 4x minus 5. It's going to be equal to 19 plus 2, which is equal to 21. And then we can undo that multiplication of 3 right there if we divide both sides there by 3. Therefore, that's going to get us then that 4x minus 5 inside of that absolute value is equal to the answer of 21 divided by 3, which is equal to 7. Okay? So at this point, what you have to understand is that now if I just have an absolute value and it equals 7, you have to think really inside of that absolute value, I could either have a 7 inside of that or number-wise a negative 7 inside of that. So originally what we actually have inside this absolute value is we have this 4x minus 5. So what we need to figure out is what x number can multiply with 4 and then have 5 subtracted from it to give us either a 7 or a negative 7 so that we get that inside of the absolute value, right? So at this point, I want to set that inside equal to 7, and then I want to also set that inside also equal to negative 7 to make that happen, right? So then I would just solve both of these individual equations. So add 5 to get the 4x alone on the left side equals 12, and then if you divide by 4, x equals 3. And then if we go to the other one, add 5, then 4x is going to be equal to negative 2, and then if you divide by 4, you're going to end up getting that x equals negative 2/4, which you're going to be able to reduce down to negative 1/2. So it does turn out that those two numbers right there are going to be the solutions. One thing I do want to emphasize about this too is that we could graph what the solution set is for this. So if that's like 0, 1, 2, and 3, and negative 1, then just the dot at negative half, and then just the dot at 3, just a couple dots, those would be the like answers, right? Just in sort of like a picture form on the graph of a number line there. Okay? All right, and then one more example that's similar in nature right here. We want to solve this equation for x, which is contained inside of the absolute value right there. So what we're going to do in order to get that alone is we're going to have to undo the dividing by 2 as well as the adding of 1. So the first thing that we can do then is undo the adding, which we can do by subtracting that number. So subtracting 1, that's going to give us then 6 on that left-hand side, which is equal to the absolute value of negative x plus 4/3, and that's all over 2. And then we can get rid of that 2, or undo that if we multiply by 2. So undo the dividing, and then we'll multiply the other side by 2. So that will give us then that 12, since that's 2 times 6, is equal to the absolute value of negative x plus 4/3, right? Okay, so at this point then, you just have to recognize that inside of this absolute value, we need to either have the number negative 12 or 12 for it to absolute value and become 12, right? So therefore, we need to look to be able to find when the inside, which is negative x plus 4/3, is going to equal 12, or when the inside negative x plus 4/3 is going to equal negative 12, and then solve that. So if you subtracted, you're going to get 12 minus 4/3 is equal to negative x. So I'm going to actually need to kind of add those couple numbers together, which means I need a common denominator. So I'm going to have to take the 12 and turn it into thirds. If you multiply by 3 over 3, you get 36 thirds, because 36 divided by 3 is still 12. And then 36 minus 4, you can now do and get 32 thirds. So if 32 thirds is equal to negative x, then positive x is going to equal negative 32 thirds, right? All right, so we get that solution, and then in a similar sort of regard, with this one here, we're going to have negative 36 thirds when I change negative 12 to thirds, and then we're also going to have to subtract 4/3, as we'd have to do to both sides there. I have that plus sign there that I'm going to erase. I don't have that there. All right, so then if we do negative 36 minus 4, we're going to have negative 40 thirds, which is equal to x. And so those two would be the solutions for that equation, okay? All right, so now as we look at kind of what I've titled right here, these are absolute value equations. So we're going to see equal signs in all of these, but you'll notice now that there's actually going to be not any more than two solutions, fewer than two solutions with these, and you'll kind of see why that is in these examples here. So jumping to this first one right here, we want to solve this absolute value equation, so I want to get this absolute value alone. So the first thing I'm going to have to do is get rid of that 3, so I'm going to have to subtract it. And that means then that we'll get negative 8/3 in front of the absolute value of x plus 1 equals 13 minus 3 gives us 10. Beautiful. All right, so then I want to get rid of the multiplication by the negative 8/3. So I'm going to have to multiply by the reciprocal. And I also want to multiply by a negative so that that negative and that negative will times be a positive and give you just x plus 1. So the other side's going to have to get also multiplied by negative 3/8, of course, right? So if we treat 10 as 10 over 1, then we can see we're going to get negative 30, and 1 times 8 is 8ths, right? Negative 30/8. You can actually reduce that number right there, or reduce that fraction. Both are divisible by 2, so you could just write it as negative 15/4 as well, okay? So at this point, like, an alarm should be ringing off in your head, because you look at this and you see, okay, I have something just absolute valued, but it equals a negative number, right? And that will never happen if you have just an absolute value, right? So therefore, it turns out that no matter what you plug in for x, like, you could plug in 6 for x, you could plug in negative 100, it doesn't matter, right? It's just that equals is never going to be true, right? So therefore, there is no solution for this equation. I do want to show for this one as well, like, what the graph of the solution set would look like, and that's what the graph of the solution set would look like, right? It's just an empty number line. You don't need to draw anything on it because there aren't any answers for it, right? All right, and then this last one here also has fewer than two solutions. So we want to solve to find the values of x that make the equation true. Okay. So you can see that there's an absolute value, you got x inside of it, so we want to get that absolute value that I put in a rectangle alone. It's multiplied by 3/5, and there's also a subtracting of 3, so we've got to undo those couple things first. So let's undo the subtracting 3 first by adding 3, right? Okay, you're going to get 0 equals 3/5 of the absolute value of negative 2/3 x plus 4. Yeah, and that cancels out to equal 0 too. Beautiful. Okay, now we want to get rid of that 3/5. So let's multiply by the reciprocal, which is 5/3 to both sides. Therefore, 0 is going to equal the absolute value of negative 2/3 x plus 4. Great. Okay, so now at this point, the absolute value equals 0, and that can definitely hold, but only if the overall worth of the inside is just a 0, right? So what that means is that this inside quantity can just equal 0, right? So we want to really just try to figure out when does negative 2/3 x plus 4 equal 0. Right? And then we just want to solve that, and that will give us the solution. So there's just going to be one answer for this equation. So if you subtract 4 from both sides first, you get negative 2/3 x is equal to negative 4. And then right here, you're going to want to multiply by the reciprocal, also a negative, so you get a positive x. The reciprocal is negative 3/2. So then we would get x alone, and then on that side, I'm going to multiply by negative 3/2 as well. So the negative 4 times negative 3 is going to give you 12 and halves, but that does reduce all the way down to 6. So it does turn out that that right there, the number 6 for x, is the solution to that equation. All right, so still sticking in the equation world here, what's a little bit different now, though, is that when I get this absolute value here alone to try to solve this equation, I'm just going to have to divide by 2. Or in other words, multiply by 1/2 does the same thing. What that means is that everything here is going to get halved, which means you get 4x minus 3 when you half those couple of terms. And then you get just the absolute value of 2x plus 12 there on the other side. So I started off by saying this one's a little bit different, and the reason why this is a little bit different is now that you got the absolute value alone, this thing that's on the other side also has an x, right? A 4x minus 3. So as we've talked about, as we've learned, it's these sorts of absolute value equations where you might run into extraneous solutions where there's a variable on the other side of the equation, not in the absolute value, right? Okay, but the idea and the concept is still the same as all these other examples that we were just seeing, right? So like if you have the absolute value of a and it equals like 15, for example, right? Then you just want to take what's inside of that absolute value a and figure out when it's going to equal negative 15, right? Or when it's going to equal 15. So you'll recognize that we want both the positive and negative versions of what's outside of the absolute value, right? So we want the same sort of thing right here, is that we want both the positive and negative versions of what's outside the absolute value. So the positive version of it would just be itself 4x minus 3, but the negative version of it would be negative 4x plus 3. Okay, and we want to be able to figure out when the inside of this absolute value, so 2x plus 12, is going to equal either of these two things, right? So I want to take the inside, keep that the same both times, but yeah, set it to equal the positive or negative versions of the thing that's not in the absolute value, right? Okay, and then you can just solve each of these two equations. So if I take that equation and I solve it, I could subtract 2x and then get 12 equals 2x minus 3. And then I can add 3, so I get the 2x alone. So 15 is equal to 2x. And then you can divide by 2, and that's going to give you 7.5, right? Cool. And then if we go to the other one, I could maybe add 4x to cancel that out. That's then going to give you 6x plus 12 is equal to 3. And then you could like maybe subtract 12. And then 6x is equal to negative 9. And then you can divide by 6. So you're going to get negative 9/6, but you'll reduce that down to negative 3/2. That's actually a very nice decimal. So just write as negative 1.5. Okay, so we get those two possible answers. But it's in these sorts of problems where, right, there's that variable not in the absolute value where it might be extraneous. So we do really need to want to check these solutions out to make sure that they're actually valid in the original equation. So yeah, let's check this out. I'll just check it out in that one. I don't need to necessarily go back to the original. So just the absolute value of 2x plus 12 equals 4x minus 3. I just want to test it out in there. So let's try the 7.5 first and see how that pans out. So what we're going to get then is 2 times 7.5 is 15 plus 12 gives you 27 in the absolute value. And then 4 times 7.5 is 30. So you end up getting an absolute value of 27 on that side, which is just 27. And then on that side, 30 minus 3 is 27. And so you get a true equal statement. So that verifies that, okay, good, 7.5 is a valid solution, right? And then we can also check it for the other solution that we got. So negative 1.5. Okay. So if we go to the left-hand side, 2 times negative 1.5 is negative 3, and negative 3 plus 12 is 9. So we get 9 in the absolute value. 4 times negative 1.5 is negative 6. So we get negative 6 minus 3. So absolute value of 9 is positive 9. And then there, negative 6 minus 3 is negative 9. And there we get a false statement. 9 is not equal to negative 9. So what that means is that x equals negative 1.5 is not a valid solution to this equation. So therefore, that's actually an extraneous solution, right? It doesn't actually work in the equation. So really the only answer for this equation is this fella right here, 7.5 4x, okay? And then this example sometimes throws people a little bit because you look at this and you see that, okay, I've got this absolute value all alone, right? And then you look at the other side of it and you see, oh, there's a negative on the other side, right? So that has to be, is that maybe impossible? But the thing is, though, is that there's also an x right here, right? And so, like, if x itself was some negative number, I'm just going to, like, make this up off the spot right now. Like, let's say negative 9 was x. Well, then that would actually be a positive, right? So this can actually hold and actually be true, okay? So yeah, if we want to solve this equation right here, since the absolute value is alone, really you just want the inside of your absolute value to equal both the positive and negative versions of what's not in the absolute value, right? What's on the other side of the equation. So the positive version of it would actually be the negative 2x, right? And then the negative version of negative 2x is actually positive 2x, right? Love how that works out. All right. And then you can just solve each of these two individual equations. So let's say we add 2x. That gives you 1x minus 6 equals nothing, equals 0, which then means x equals 6. And then if you go to the other one, let's maybe add x. That means negative 6 equals 3x, and then you can divide by 3, and then you're going to get negative 2 is equal to x, right? So you get those two possible answers, and then you're going to want to go and plug both of them in to see, if they're going to work out okay. So if you tried plugging in 6, you'd see you get negative 2 times 6. Already you could hopefully maybe tell that this isn't going to work out because now you're going to get a negative 12, right? But it equals the absolute value of whatever, so it's not going to work out. So it turns out that 6 is extraneous. But if we go with the negative 2, plug in negative 2 equals absolute value of negative of negative 2 minus 6. Right there you get 4. And then you'd get negative and negative 2, so 2 minus 6. And 2 minus 6 is negative 4. But when you absolute value, you get 4, right? So that checks out okay. So it turns out that negative 2 would be the solution to that equation then. All right, so finally, jumping to some inequalities right here, right? Okay, so we want to solve this inequality, right? You can see there's a greater than or equal to, but really what matters though is that let's first of all get this absolute value isolated, and then we can talk about conceptually what's happening, right? So whether you're solving an equation, whether you're solving an inequality, whatever, get that absolute value alone, okay? So we want to get rid of that negative 2 that's timesing, so let's go ahead and divide both sides here by a negative 2. Now, because we're dealing with an inequality, right, we know that when we multiply or divide both sides by a negative number, that inequality symbol is going to flip directions, right? So it's going to become a less than or an equal to, because we're divided by that negative. So the absolute value of 4 minus 2x will become less than or equal to, and the answer right there, negative divided by negative, will be a positive, actually gives you 22, okay? All right, so here's the thing, is that you really need to think about what you're plugging in inside of the absolute value that's going to make this hold and be true, right? And just think about the numbers that you could plug in. So you could plug in something like 21.99 into this, and 0.99, right? But you can't plug in like 22.1 for this to be true, right? So you could plug in 21.999, you could go all the way lower, all the way to 0, but there's also some negatives you could plug in. And it turns out that like the smallest negative number that you could plug in is like negative 21.99. So basically all of the numbers between negative 21.99 and 21.99 are numbers that when you absolute value them, right, will still be less than this positive number 22, right? So you want to use that thinking to help you understand what we need to do from here, right? So when you have something like this, right, and there's like 4 minus 2x inside of there, what I just brought about is recognizing that inside of this absolute value has to be anything like from negative 22 to 22, basically, right? I need the inside of what's in the absolute value to be something that's between negative 22 and 22, right? So if I need the inside to be between that, I really want to set up like a component inequality where smushed between negative 22 and 22 is the inside of my absolute value, which is just that linear expression 4 minus 2x, okay? So then we can actually now solve this because we solved component inequalities, right? I just want us to get the x alone, so first I can subtract the 4 from everything. That's going to give you then negative 26 is less than or equal to negative 2x is less than or equal to 18. And then you can divide by negative 2. And then you're finally going to get 13, and that'll be just x and negative 9. Now, because in this step right here, we divided by a negative, then these symbols here are going to flip directions. They're actually going to now both point that way, but we know that we always want to make sure that we actually write the smallest number at the left. So just kind of want to flip this inequality around, so the negative 9's at the left side, and the bigger number, 13's at the right side. And then it points like this, and then it turns out that those numbers right there are going to be the solutions to that inequality right there. So as like a graph, if this is where negative 9 is at, and this is where 13 is at, then all of the numbers between negative 9 and 13 with closed dots, because you have the equal to's, would be the solutions to that inequality. And then jumping over to this example right here, We're asked for the solution set of this inequality. You can see that x is inside the absolute value again. So really your goal, first of all, is to get this guy here alone. So the first thing we're going to do then, I guess, is let's undo the subtracting of 8. So let's add 8 to both sides. Do that step first. Right there, you're going to get 6 is less than 1/3 of the absolute value of 3/2 x minus 3. And then you can undo the multiplication of 1/3 if you multiply by 3. So then 18 is going to be less than the absolute value of 3/2 x minus 3. And cool. All right, so now if 18 needs to be less than the absolute value of 3/2 x minus 3, another way you could think about this too is you could say 3/2 x minus 3 when you absolute value it, right? It has to be more than 18. That's the same thing, right? So those mean the same thing. Is that if that's going to be true, then number-wise, basically anything that would be like an 18.1 or higher, right? But also a negative 18.1 or lower than that, like negative 18.2, negative 19, negative 20, that sort of stuff. Those sorts of numbers, but nothing between, right? So really what needs to be true about the inside of this absolute value, so this 3/2 x minus 3, is you need this 3/2 x minus 3 to either be more than 18, or you need it to actually be less than negative 18, so that the result of then absolute valuing any of those numbers more than 18 or less than negative 18 will actually result in it being greater than 18. So what that means then is that 3/2 x minus 3 being more than 18 would look like this, or 3/2 x minus 3 being less than negative 18 is going to look like that. All right, and so therefore, then you can just solve those couple of inequalities. Then you'd get 21, and then you would multiply by the 2/3 then. So 21 times 2 is 42, and 42 divides by 3 is 14. So yeah, we would get x is greater than 14 for that one. And then for the other one, if you add 3 to negative 18, you get negative 15. And then you can multiply again by the reciprocal 2/3. 2 times negative 15 is negative 30, and negative 30 divided by 3 is negative 10. So we would get that x would be less than negative 10. So that right there, x being a number bigger than 14 or x being a number less than negative 10, is going to be the solutions. So on a graph, if that's where negative 10 is and that's where 14 is, then you would have open circles, and they would point in opposite directions like that. So you'd get the numbers less than negative 10, or the numbers that are greater than 14. All right, and then just a couple last things to wrap this up here. There's just a couple special cases of the inequality sorts of things that will happen. So yeah, let's take a look at this first fella right here. So we want to solve it. Let's get the absolute value here alone. So we want to, I guess, first of all, undo the plussing of 3. So let's go ahead and subtract 3. That means then negative 3, absolute value x minus 3 will be less than or equal to 6 minus 3, which is 3. Lots of 3's here, right? Okay, and then we're going to want to divide by the negative 3 there. So we cancel that out and divide there by negative 3. So we get negative 1 on that side, and then absolute value of x minus 3. And also what will happen here is that inequality symbol is going to flip at this step because we divided by a negative. So now it's going to be a greater than or equal to. And yeah. So now when you think about what's happening right here in terms of if I'm going to absolute value something and I want it to be more than negative 1, well, how often do you get something to absolute value and they be more than negative 1, right? Well, you think about absolute value, right? This is always going to be either 0 or higher, right? Positive, and that's negative, and that's saying that it could be greater than or equal to, right? So isn't that always going to hold? And the answer is, yeah, it's always going to hold. No matter if x is like equal to 100 if I plug that in, or if x was equal to negative 99, it doesn't really matter what I plug in for x. So it just turns out that this statement is always going to hold no matter what x is, right? So therefore, x could be any number we want it to be. So therefore, x can be any, and we'll just say a real number, because if it's any real number, it could be any number on the number line, right? So therefore, if this is the real number line, then all of these numbers going towards negative infinity and towards infinity, right? Basically coloring the entire real number line would show us a picture of the solution set for that. With this last example, there's a few things that I want to tweak about it. And so the first thing I want to tweak here is that -10. I'm going to change it to be a +10. And then the second thing is, instead of that being a greater than symbol, I want it to start off by being a less than symbol. And then we'll take this and solve this from here. Okay, so we have this x variable inside the absolute value, so we're going to want to isolate that absolute value that's in the rectangle there. So we'll have to get rid of the -1/4, as well as undo the subtracting of 8. So we'll have to start with that subtracting of 8. So let's go ahead and add 8 to both sides right here. So that was a +10. So 10 plus 8 gives you 18. And then it's a less than still -1/4, the absolute value of 5/2 plus, and then it's 3.5, which is a mixed number. I'm just going to write it as 7/2 improper fraction, same thing. Okay, so then we jump to this here, and we're going to want to get rid of the -1/4, so we can multiply by the -4 to make it become just a +1 in front of the absolute value. So the inequality is going to flip, can become a greater than, because we multiplied both sides by a negative. On the right-hand side, you have the absolute value here. And then on that left-hand side, the answer to -4 times 18 is the number -72. And so now we've landed here. Okay. So I could rewrite this if I wanted to by putting the absolute value over here. And then since -72 is greater, then it's got to be less than -72, right? So if you think about this and think about, okay, so like what could I plug inside the absolute value in terms of like numbers that then will absolute value that number and then make it less than -72? And that's a little confusing, because whenever you absolute value, it should always be positive and not be less than something that's negative, right? So it doesn't matter then what you plug in for x right there then, because it's never going to be less than -72, right? So this statement right here will never be true for any value of x. So therefore, there is no solution to that equation. And yeah, as a picture, you just would have an empty number line showing you all of the, or none of the answers that x could be, right?